So Dalton's atomic theory was based off three laws. There was the law of conservation of mass, which states that matter doesn't get created or destroyed in chemical reactions. The second law was the law of definite composition or definite proportions, which states that for a pure substance you have the same ratio by mass of the elements in the compound. And the third law is the law of multiple proportions, which states that atoms of the same elements can combine in different whole number ratios to form different compounds. So we're going to use this data right here to show all three of these laws. So there were 3 experiments performed where you had a sample containing only carbon and oxygen that decomposes into those 2 materials. So you have an initial sample, that's both of the materials, and then you have the oxygen isolated and the carbon isolated. So for all of these, what you should notice, and let's just look at the first one, that the mass, the combined mass of the products adds up to the initial mass of the sample. So your products and the reactants have the same total mass. That demonstrates the law of conservation of mass. Again, matter is not created or destroyed. Then secondly, what we can do is we can find the mass of oxygen to the mass of carbon ratio in each of these compounds, and then we'll compare them. And we do that over here. So for experiment 1, which I tell you is compound A, and experiment 2, which is also compound A, even though you have different amounts of the sample, you have the same ratio of the elements by mass. So you have 2.7 grams of oxygen for every gram of carbon that you have in each of those experiments. Thus, again, law of definite proportions, you have the same ratio of the elements by mass, no matter the sample size or where the sample's from for a given substance. Then, lastly, we can compare either experiment 1 or 2, but compound A to compound B, and we'll see that there's a different ratio. So compound A, again, 2.67 grams of oxygen per gram of carbon by mass. Compound B is only 1.33. When we compare those ratios, we get a whole number. So when we divide the ratio in A for B, we get a ratio of 2 to 1. And what that implies is that compound A has twice as much oxygen relative to the amount of carbon as compound B. So for example, this could potentially be, and this doesn't definitively state this, but it could be carbon monoxide would be compound B, and carbon dioxide would be compound A, where you have twice the relative mass of oxygen in compound A.